Let's go over confidence intervals for the mean. Question 1. In 2011, the U.S. Department of Transportation reported with 95% confidence that the average length of a motor vehicle trip in the United States was 9.72 miles. So they're claiming, in this case, they're claiming that the sample mean is 9.72 miles, with a margin of error of 0.22 miles. With 95% confidence, the authors of the report are claiming that the true average length of a motor vehicle trip in the United States is between what and what values? So we know the formula for the confidence interval, x bar plus or minus z times sigma over the square root of n. Now this is called the point estimate. X bar is the point estimate. We already know the point estimate is 9.72. Now, this number on the right here, z times sigma over the square root of n, that's our margin of error. Z times sigma over the square root of n is our margin of error. And they told us what this was equivalent to. We know the margin of error is 0.22 miles. So for this question, I'm going to take x bar, which is 9.72 miles, and we're going to add or subtract the margin of error to that, and that's 0.22. And so we can use our calculators. We can subtract 0.22 from 9.72, and then we'll do the addition. And so we have 9.72 minus 0.22 gives us 9.5. And then we'll do it again. We'll do 9.72 plus 0.22. And that gives us 9.94. So with 95% confidence, the authors of the report are claiming that the true average length of a motor vehicle trip in the United States is between 9.5 and 9.94 miles. The level of confidence for this estimate is, of course, 95%. Question 2. All else equal, an increase in the sample size would cause a decrease or increase in the size of a confidence interval. Do not guess on this question. In order to figure this out, I'm going to review the formula for the confidence interval. Now here we have x bar plus or minus z times sigma over the square root of n. What would happen if the sample size were to increase? Well, n would get bigger. This n would be bigger, and since we're dividing by a larger number, what do you think happens to the value of z times sigma over the square root of n? This would become smaller. Since I'm dividing by a bigger number in the denominator, the overall value of z times sigma over the square root of n would be smaller. X bar is our point estimate. We have our point estimate, and we're adding or subtracting z times sigma over the square root of n. That's our margin of error. What would happen if you're adding or subtracting a smaller margin of error? Well, that would decrease the size of the confidence interval. For question 3, all else equal, an increase in the level of confidence will cause a decrease or increase in the size of a confidence interval. Now again, I'm going to refer back to the formula x bar plus or minus z times sigma over the square root of n. This time we're increasing the level of confidence. That means we're changing the value of z. So if I'm increasing the level of confidence, what happens to z? Well, z gets bigger. Z gets bigger. And if I'm multiplying by a bigger number, what happens to my margin of error? It gets bigger. So I'm adding and subtracting a larger margin of error. Therefore, the size of the confidence interval will also increase. You could think of it this way. For question 2, as we get more information, our level of confidence starts decreasing. We're narrowing our possibilities for the mean. In question 3, I'm being more confident, so I'm actually increasing my confidence interval so I can be more certain that I'll be right. Think about a basketball hoop. The larger the hoop, the higher confidence I will make the shot. Question 4. In 1998, an advertising campaign, the Nabisco company announced a 1,000 chips challenge, claiming that every 18-ounce bag of their Chips Ahoy cookies contained at least 1,000 chocolate chips. Dedicated statistics students at the Air Force Academy, no kidding, purchased some randomly selected bags of cookies and counted the chocolate chips. Some of their data are given below. Find a 95% confidence interval for the mean number of chips in a bag of Chips Ahoy cookies. For this question, we could definitely do it by hand, but we'll be forced to find the sample mean. We'll be forced to find z, the standard deviation of the sample, and divide it by the square root of n. This is going to take a lot of work, especially for that standard deviation. So this is actually a calculator question. Let's type all of these values here into our statistics calculator. Let's go to the confidence interval calculator with data. And now we'll enter the values of the chocolate chips from the students and make sure you have a comma in between each of the values. And then click calculate after we enter 0.95 because we want a 95% level of confidence. And now click calculate. Here is our lower limit, 1187.94, and our upper bound is 1288.42. Now let's answer the question. We are 95% confident the interval for the mean number of chips in a bag of Chips Ahoy cookies is between 1187.95 and 1288.43. Based on this confidence interval, is the Nabisco company justified in making this claim? Yes, they are justified in making this claim. If you look at our confidence interval, we have numbers that are larger than 1,000. They're claiming at least 1,000 chocolate chips per bag of their Chips Ahoy cookies. Since we are 95% confident that their interval is larger than 1,000, we believe them. We are 95% confident that they're telling the truth. Question 5. Many people feel that cereal is a healthier alternative for children over glazed donuts. The table contains the amount of sugar in a sample of cereal that is geared towards children. Estimate the mean amount of sugar in children's cereal using a 99% confidence level. Round to one decimal place. In this question, we're going to again use our statistics calculator. Let's enter our values into our calculator, the confidence interval calculator with data. Now we have entered all of the values from the data table, and now we're going to construct a 99% confidence interval. So enter 0.99 and click calculate. Now it gives us a confidence level, the lower bound and the upper bound, and it also gives us the sample mean. We have the lower limit is approximately 9.8 and our upper limit is approximately 11.9. Now let's go back to the question and answer it with 99% confidence. It can be said that the true mean amount of sugar in children's cereal is between 9.8 and 11.9 grams of sugar. Question 6. In a survey, 30 people were asked how much they spent on their child's last birthday gift. The results were roughly bell-shaped with a mean of $46 and a standard deviation of $10. Construct a confidence interval at a 90% confidence level. Give your answers rounded to one decimal place. In question 6, I want to do the work by hand first, and then we'll use our calculator to make sure we got the right answer. Now, notice that the sample size here is 30. This is less than 1,000. 30 is less than 1,000, so we're going to use the formula x bar plus or minus t sub n minus 1 times s over the square root of n. Now in this case, we know that the sample mean is 46, so x bar must be equal to 46. To find t sub n minus 1, we'll have to go to our t table. Now in our t table, I want to find the value of t for a 90% level of confidence. So we do 1 minus the level of confidence divided by 2. And so that's 1 minus 0.90 divided by 2. And this is equal to 0.05. So the column that we need to use is 0.05. Now which row do we use? Well, that depends on n. N is equal to 30. So we're going to use the degrees of freedom equal to n minus 1, or 30 minus 1, which is 29. So let's use row 29. Here's row 29, and we'll intersect the column 0.05. That means we're going to use 1.699 for the t value. So we'll use 1.699. So t sub n minus 1 equals 1.699. S is our sample standard deviation, and that is $10. The sample size, we know it's 30. So let's plug in all of these values into our formula. And so we have 46 plus or minus 1.699 times 10 over the square root of 30. Let's do the right side of the plus or minus first. This gives us 3.1. So now I can add and subtract this from 46. And our lower limit is 42.9, and our upper limit is 49.1. Now we can say we are 90% confident that a parent will spend between $42.9 and $49.1 on a child's birthday gift. Now let's check our work on our statistics calculator. I'm going to use the confidence interval calculator with statistics. And so I enter the sample size is 30. The sample mean is 46. The standard deviation is 10. And the level of confidence is 0.90. And this gives us 42.9 and 49.1, which is exactly the same as what we did by hand. So we know we did this problem correctly. Question 7. If n equals 29, x bar equals 34, and s equals 7, construct a confidence interval at a 99% confidence level. Assume the data came from a normally distributed population. Give your answers to one decimal place. We will use the formula x bar plus or minus t sub n minus 1 times s over the square root of n. Now, the degrees of freedom is equal to n minus 1, and in our case, it's 29 minus 1, and that's equal to 28. Since the degrees of freedom is less than 1,000, we're going to use this formula with dt in it. If this was greater than or equal to 1,000, we always use the formula with the z in it. So let's find our t value from our table. To find the column that we need to use the formula 1 minus the level of confidence divided by 2. In our case, the level of confidence is 99%, so let's subtract 0.99 from 1 and divided by 2. This gives us a value of 0.005. So that's the column that I'm going to use. The column that says 0.005. Now, which row do we use? Well, that depends on our degrees of freedom, which we know is 28. So let's go to the row that says 28. And now we have our t value that we need, and that's 2.763. So let's use that number, 2.763. We know x bar is 34. We know n is 29. And our standard deviation is 7. So let's plug the values into our formula. 34 plus or minus 2.763 times 7 over the square root of 29. Again, let's calculate the right side of the plus or minus first. This gives me 3.592. And now we can do 34 minus 3.592. That gives me 30.408. And for the upper limit, we'll do 34 plus 3.592. That gives me 37.592. Now let's round these to one decimal place. We are 99% confident that the mean is between 30.4 and 37.6. Now let's go to our computer and check to make sure that these answers are correct. Enter 29 for the sample size, 34 for the sample mean, 7 for the standard deviation, and 0.99 for the level of confidence. Click calculate, and we get exactly the same solutions, so we know that our answers are good.